My name is Ermolaev. I work for ChangeHealthcare, which is one of the largest independent healthcare technology companies. My role is Director of AI, which I'm responsible for implementing AI projects for the corporation. Actually, it's interesting, but my original education was in AI more than 20 years ago. Back then, it was called cybernetics. And that's the field which didn't get a lot of attention, so I spent a large part of my career working on traditional business software projects. And in the last 5 years, I did get a chance to work on AI projects over the years, quite a few. And for the last 5 years, I'm working on AI full-time. So within ChangeHealthcare, we have more than 150 different products, which do all kinds of things for the healthcare industry, managing a lot of medical claims. We have one of the largest medical imaging solution called PACS. We have solutions for scheduling, for risk adjustment, medical coding, etc. It's a large corporation. So what we do at ChangeHealthcare is try to apply AI to all kinds of business units we have. And sometimes we have an optimal solution where AI is a good match for the product needs. Sometimes it's not. But if you think about the company of that size, the number of opportunities is simply, tremendous. And we not always able to implement everything right away. So we try to prioritize our projects and do things that generate the biggest impact first. Yeah, AI is applicable to a very large number of use cases. It's a very broad type of technology. AI systems are basically learning systems or pattern recognition systems, which do two things: detect and predict. And if you think about the world around us, those type of detection or prediction problems, they're everywhere. Or optimization, by the way. Optimization is another application. But the most commonly, it's either detection or prediction. So if you look at healthcare, many of the diagnostic problems in healthcare are actually detection problems. Many of the treatment plans, those are prediction problems, where you try to find the plan or treatment option which is ideal for each individual patient so you can improve his condition. So in medical imaging, for example, AI can solve a lot of different problems. A lot of the work that radiologists or oncologists do on a daily basis is looking for particular patterns, which is something that AI can definitely help with. What we need to remember is that AI is actually not a replacement for human intelligence in most cases, because AI is good for certain things and the human are better at other things. AI is very good at detecting the things it's trained to detect, which is usually one small part of the image and nothing else, while human minds is better to understanding the entire situation, seeing the entire picture, and have enough judgment to recommend a solution. Yeah, narrow focus AI has been very common. And I think it's understandable because business leaders are trying to generate results in order to go for a bigger project. But narrow AI projects are not necessarily ideal because they're small in scope and doesn't necessarily generate enough excitement across the company to move the AI forward. So one of the approaches that we are trying to use inside of ChangeHealthcare is actually educational approach. So we actually developed classes, training on AI available to every single employee across the company. We know it's coming. It's going to have a big impact on our business. It's best for us to train every single employee on what's coming and what to do about it. I think different people need to have different level of training. In case of ChangeHealthcare, we're a data company, so AI is applicable to almost every employee type job. It's not necessarily the case for every company. But you need to provide different level of education for different roles within a company. People working with data obviously need to know about AI. Top of the board and the top management needs to have understanding how AI works. And they don't necessarily need to do AI. What they need to understand is where AI is applicable and where it's not. One example is that many of the problems in the AI world actually come from business executives. When they ask for AI to do something that is not possible during the current state of technology, when they have expectations that are out of whack or have a knowledge which is not accurate, and then they make requests which cannot be implemented, using technology of this time. So it's very important for business executives to understand what to ask for. It's also important for business executives to ask the right questions. For example, it's very easy to ask a question, can AI solve that? But let's say, customer lifetime value or something like that. And if you ask this question of a data scientist, can you design a model which predicts customer lifetime value? The data scientist will say, yes, of course I can, right? I'm a data scientist, I know my tools, I can do the model. But this is often the wrong question to ask, because the real business problem is not to build a model. The real business problem is, can you produce commercially viable model for customer lifetime value, which can be implemented using the data and the processes we have today, which is half of the data missing or whatever it might be. So it's very important for a business executive to structure equations in a way which is actionable and can lead to a successful outcome. I think it's very important to start with a problem that you are trying to solve, and then don't assume that every problem is going to be solved using AI today. Have a list of problems, but start with a problem. The problem should be very big. It should be expensive. If the problem is not expensive, you're probably not going to go through the problem of doing all the work necessary to make it happen. Because in many cases, it's not just AI development, but also data and the integration, building the platform, training the people, building the team. All those things kind of add up to a significant cost. So what you want to do is use AI to go for your biggest and most expensive problem. The second, there has to be a pattern there. So if pattern does not exist, the AI is not going to find it. So the pattern should exist there. And the easiest way to know whether the pattern exists is just to use your team and say, can you see what's going on? Like, is there logic behind what's happening in our business? And if there is a logic and there is a pattern that you can find, then you can use AI to find the pattern as well. And finally, you need to have a data. The data is a big problem. Most corporations think that they have the data, but what they have is far from ideal. The data has to be labeled. It has to be clean enough. What's clean enough is obviously not an obvious question, but in many corporate environments, the data is not collected in a systematic and repetitive and accurate enough manner in order to qualify. So it's very important to have clean and labeled and accurate data. So once you identify the problem, which is suitable AI and justifiable from economics point of view, you start implementing it, which basically means creating a team and building the infrastructure necessary to build a solution. Building a team also not easy. AI experts are in big demand at the moment. But you still have to find a way to get at least few strong people on the team. Because otherwise, it's hard to ship a successful solution if you don't have strong leads. So team is very important. When assembling the team, it's important to have a mix of skills. Many people don't pay enough attention to the balance of the skill set between different expertise. You need machine learning experts or data scientists. You need software engineers who are good at what they do, building scalable, efficient solutions. And you need subject matter experts, because if data scientists don't know the problem, intimately enough, they're not going to come up with a solution which makes sense. The last thing about the team, the best practice today is to have a centralized team, centralized AI team, which is reporting to CEO or somebody, an executive team. So you have one central AI team which works on projects across the company. Why it's more effective? Because you have a centralized pool of limited talent, which you can apply to the best opportunities across the whole company. So when designing the team, I think everything is important. I think the most important is probably have a strong leads. So in some cases, you might have to delay the AI projects until you have people who can lead the projects. Because if you don't have enough of a team and you try to jump in, there is still value in experimentation, but it's going to be experimentation without a positive outcome. So if your goal is to learn from your own mistakes, then you can start without having any expertise. But if you have a project that you want to deliver on time and budget, experience makes a lot of difference. There are a lot of misconceptions that business leaders have around AI. We often see a question where people think AI can solve problems that humans cannot solve. And it happens all the time where people come to us and say, well, our team cannot solve something. And there are plenty of problems like that. Can you use AI to solve this problem? There are cases where it's possible, but this is generally not the best way to use AI today. The best place to use AI is to find a problem which is routine, mundane, well understood, performed in very large quantities, which you can simply automate. It's a task which you can automate, save a lot of money or improve your revenue, deliver better value to your customer without reinventing the wheel. All you're trying to do is automate something that's simple, routine, and repeatable. So I think AI in general is a set of tools. People shouldn't think about AI as one thing. It's a collection of tools. You have a toolbox where you have a hammer, you have a screwdriver, and et cetera, et cetera. And what you want to do is, for every problem at hand, you try to find the right tool for the right problem. If you think of any specific industry, you can probably find the right tool for every problem at hand. For example, in healthcare, you might want to use reinforcement learning to prescribe drug regimen to cancer patients, for example. That's very much a reinforcement learning project. If you want to try to do hospital operating room scheduling, that's a traditional optimization problem using more of a standard old-fashioned AI. So there are several architectural challenges that business leaders often face when implementing AI projects. You need to have effective infrastructure in order to do compute. You need to have a strong team which can maintain the models. The models will tend to degrade over time in the accuracy of their predictions. So it's very important to continue working on the model and improve them. I think it's important to acquire the expertise in building AI solutions. And many business leaders start from small-scale experiments where you have a project which is moderate in size, and you try to learn from it. The outcome might not be necessarily a huge success, but you're going to learn what's working, what's not, what the requirements for the data, what kind of team you need, what kind of infrastructure. And sometimes the best way to learn is to learn from your own mistakes. Or you can take a course from Udacity and learn this way. So some of the best applications of AI for manufacturing would be preventive maintenance, where you can improve how you use expensive plants or engines or things like that, and how when you maintain and how do you keep them working effectively. For financial services, a lot of it is how you implement transactions, how do you work with customers, In general, all of the customer-related stuff, sales and marketing, is very great applications of AI, and the learnings you get from that type of customer interactions applicable across all industries. So when people think about AI, sometimes they often look for the moonshot project, like solving a cancer or something like that. And at some point, we will get to that point. But in the first steps will probably be not solving the cancer, but something much more immediate. For example, find the biggest inefficiency you have in your industry. So if you think about healthcare system in the United States, huge amount of money is wasted on things like unnecessary procedures or billing errors or fraud or waste and abuse. So there are a huge amount of money which is wasted unnecessarily. For example, let me give you an example that we recently worked on. It's a medical claim denial problem. So every time the hospital provides a service to you, they submit a bill to insurance company. The bill goes through ChangeHealthcare most of the time. And about 9% of the time, the bill gets denied. The amount of money that gets stuck in this denial process is $260 billion. So it's a huge amount of money which is wasted or not received by a hospital due to inefficiency we have within a system itself. And this is one of those things that are kind of very low-hanging fruit, where you can create a lot of improvement and get significant returns due to the fact that the system is functioning not in an efficient way. Yeah, the amount of money which get wasted is pretty tremendous. In order to implement AI solutions, you have to go through the steps we already discussed. Find a big problem, make sure there is a pattern. So you have to find a way to find a pattern in the data. So if you can train AI algorithms on large enough number of claims and figure out which ones get denied and why, then you can use AI to solve the problem. In many cases, you need a lot of data, so the data has to be labeled, clean, etc. So you still have to go through the same step we discussed in order to solve those problems. Yeah, people usually say that data scientists spend between 5 and 20% of their time on designing AI algorithms and the rest on data pipelines. From the experience I have in the industry, I think that's about right. So majority of the time is spent on getting the data, preparing the data, normalizing, etc., all the work you need to do in order to build a data pipeline before you can run AI algorithms. Yeah, ethics is a very important question. It kind of gets a lot of attention at the moment. I think we need to remember that AI does not create a new problem. The issue is that AI is very good at learning that the problem already exists and might learn this problem and repeat it or propagate the problems that already exist in the system. And this is potential problem, but it's also an opportunity for a data scientist. So if you have a wonderful AI tool which can allow you to find a problem with an existing system, what if you have ability to address those problems? So AI is not just has a chance of propagating an existing problem, but also offers us an opportunity to solve the problem we already have. The problems come either from existing data or from existing business practices, which is usually the same thing. So the ethical bias issues exist in the system. So AI can propagate it, or it can be used to solve those problems. And my hope is we're going to use AI to address many of the ethical questions at hand. I think there is a lot of work that can be done to improve the way AI algorithms work. On data collection, I think many of the companies can do much better job at keeping better data, keeping it curated, accurate, and consistent. We can probably do better job on building the technology stack for AI. Right now, a lot of the AI applications run on the technology we have today. We have an opportunity to build a bigger and better technology stack for that. Understanding AI, where it works, where it doesn't, I think we're in very early stages. And we're trying to imply in areas where we kind of see AI as an obvious match. But there are probably many, many different areas where AI can be very central to the future, but require us not just plug it in, but redesign the particular industry or particular segment around the new capabilities. So I see AI is the next loan wave. Each loan wave lasts about 55 years. The previous loan wave was a computing technology which started from semiconductor circuit and went through building databases, business applications. And now what we end up is restructuring society around the information technology where people can work remotely, where shopping is done online, all of those kind of byproducts of the original innovation, which is integrated circuits. With AI, we're going to go through some of the similar processes. First, AI is a little bit research-oriented, small set of projects, which basically use to learn more and become better at it. Over time, it becomes more of a scale problem where we start using AI for a large number of different applications. But the ultimate value of AI will come when we start restructuring society around those new capabilities. So let me give you an example. For example, there is plenty of research done on early diagnostics. For example, you can predict onset of Alzheimer 5-6 years earlier. But right now, we can predict it, but we cannot do anything about it. So I think we get to a point at some point in the next 10, 15, 20 years where we have the ability to predict things like that. And we also will have procedures or treatments to address the problem at hand. And so AI is a part of it, and there are other technologies around it which will allow us to solve many of the problems that have been unsolvable up to this point. I think there is opportunity. AI will roll out over time. There is an opportunity to do things today. Right now, it's a little harder to do because technology is new and the tools are still evolving. Over time, the AI will be much easier to use, much easier to imply. So at some point, we'll have AI applications that look like Excel, right? There is nothing prevents us from using a lot of intelligence between very, very simple consumer-oriented tool and providing people the value that they need through very easy-to-use interfaces. I think we're going to get to this point in the not too distant future. So some of the early stage applications depend on the industry. As we mentioned before, it's important to find a very big problem. For, let's say, airline industry, trying to do preemptive maintenance on airline engines, that's a huge opportunity where you can save millions and millions of dollars. In healthcare, that might be more related to financial administrative part of the industry, because those are problems we can solve today. We have the tools, we have the technology. We still need to have a way to implement it more effectively within a workflow and a healthcare system. But a lot of things that's already in place. If you think about medium term, maybe on the airline industry, we're going to start new engine design, right? Why does it have to be round and made from steel? Maybe it will be something totally different. On the healthcare side, we're going to get a lot of diagnostics, which can be possible using AI. And longer term, I think the opportunities are open to everybody. You can dream whatever you want to dream. I think a lot of things will be possible longer term, and I don't know if I'm the most creative person to answer this question. Yeah, the preventive maintenance problem is good for manufacturing industries. We can potentially apply it to humans, but we have to do a lot better at data collections than we're doing today, because we need consistent screens done across all kinds of sensors. And right now, the healthcare system usually reacts to the problem once they're already evolved. But we have an opportunity to do preemptive screening across large number of data points, where we can actually predict who is going to develop particular condition or particular disease years ahead of time. It's actually very interesting, but prediction problem in healthcare, you can predict many things many years in advance. Human body is living organism. It's not random. Things happen slowly over time. And you can see early onset on different conditions much earlier than you could in the past. So one thing is you need to train yourself and train the people around you. It's very important. Join groups, join forums, go to the conferences, learn how it works. Right now, we are only scratching the surface. All of the AI conferences are very busy and getting a lot of attention. But if you think about it, it's very small percentage of people get involved in AI in any shape or form. We need to increase the number of people involved in AI by an order of magnitude or 2 orders of magnitude before we can realize the full effect of this technology.